So hello everyone. Today is lab 5 about Kubernetes. So in this lab you will learn about the hands-on part of Kubernetes. So I'm assuming that you have attended the lecture of Kubernetes by Professor Lu or watch the video as if not attend the lecture. So because we are not going to do the theory part, we are going to do hands-on of Kubernetes. So that is the prerequisite to know the basics. So in this lab we'll do the hands-on on running the Kubernetes locally and then running the Kubernetes on GCP. So I'll show you both of the ways to deploy your application on Kubernetes. And then I'll also explain other services of GCP, such as artifact registry and cloud build, which will be used for your Kubernetes assignment. So Professor might have already explained you this, but I'll just give a brief of Kubernetes architecture. So Kubernetes has two main things. First is control plane and the second is worker node. So first of all, let's go to the worker nodes. So worker nodes are basically clusters, and in that you will have a kubelet agent. So all the worker nodes will be having kubelet agent running in it, and it will see if all your application is running or not. So it is the main goal of this kubelet agent. And the main part is control plane of Kubernetes. So let's say I'm using Google Kubernetes engine or my local version of Kubernetes. So this is me. So when I fire any API, such as API to create a cluster or to deploy my application on Kubernetes, it will first go to this control manager, and it will go to this API, which will listen to all the APIs incoming, and then it will. So let's say I have gave a query of create deploy my application. Then this API will tell the control manager that I need a pod or a deployment, and then this scheduler will listen to this request. If the user has asked for a deployment or service or pod, then this scheduler will schedule it and create it. And then this etcd is the storage thing in Kubernetes, so you can store your secrets in this etcd or some storage. So all the storage thing is handled by this. So this is the brief of Kubernetes architecture. So to see it in depth, I will highly recommend to see the video of Professor Lu's lecture for Kubernetes. Okay, so this was the component brief. So you can also review this documentation by Kubernetes. It is very good. So if you want to know about the in-depth work of Kubernetes, then you should go through this document. It has everything from the basic and what are the things, important things that in Kubernetes. So you can go through this web page to understand the concepts. Okay, so next part is how to run Kubernetes locally. So to that you can do two things. First is to use this MiniKube or use Docker. So if you have Docker installed on your machine, you can go to settings, and then there is Kubernetes button, and just check this mark and then apply and restart. So it will install Kubernetes on your machine. Otherwise, you can use this MiniKube. So it is minify lightweight version of Kubernetes, which is used in your local machine or any server. So it needs Docker in backend. So the prerequisite will be Docker install, and you can install if you have 2 CPUs or more and 2 gigs of RAM and 20 GB of free storage. So these are the requirements. So it is supported into all the OS, Mac OS, Windows and Linux. So you can just follow this documentation to install the MiniKube. I have used MiniKube for this lab because I like this better, but you can use anyone to learn this. So why I mention this, because you have 50 credits for GCP, right? So GKE, Google Kubernetes Engine, is very costly, and if you keep it running, then you might drain your credits. So for learning purpose, you can use MiniKube or local Kubernetes, and you can mess it up. It will be fine. But if you mess something up in Google, then it will consume your credits. So to learn, it's better to use this than that. And then for production, for assignment, you can use GKE. So just a suggestion. Okay, so after it is installed, you need to run MiniKube start command. So I have already run it because it takes some time to start. So it is already running on my machine. So first of all, let me ask a question. So why Kubernetes? Anyone? So we learned about Docker, then Docker Compose for multiple containers, and then now it is the third part, which is Kubernetes. So why we need Kubernetes in the first place? Why Docker is not enough? So basically, Kubernetes is used to orchestrate the containers. So in simple terms, it is used to manage your containers. So let's say I have I'm the developer of Instagram, and let's say, and how many users might be for Instagram? Millions, right? So you might get millions of requests per second. So do you think one container will be able to serve all the requests? You will need multiple containers, so that let's even 500 or thousands of containers with big CPU, big memory, so that they'll be able to serve this million requests coming per second or millisecond. So at a large scale, you need something massive which can handle the load. So that comes the Kubernetes. So we use Docker to containerize our application, but Kubernetes is used to manage those containers. You can scale the containers up, scale the container down, you can deploy your containers. You can have multiple deployment patterns in Kubernetes. So that is not in the scope of this course, but you should learn the deployment patterns of Kubernetes. So the gist of it is that it helps to manage the containers, and Kubernetes is very powerful. So that is the basics of Kubernetes. So let's do some hands-on. Any questions so far? Okay, so I've installed this MiniKube on my machine, so I'll just go to terminal. So to run my application, I need like an image, right? So I'll just first create the image. Okay, so I have created a basic Flask app. It has one API route, base route, and Docker file. So it is just a simple Flask app. So I'll containerize it. So I'll just first build the image. And the one thing about Kubernetes is like it is used for deploying applications. So you can't build the application locally and then deploy it on Kubernetes. You need to push it somewhere like Docker Hub or Elastic Registry in Amazon or Artifact Registry in Google. So I'll build this image. So I'll just write Docker images. Let's see from the console if it is there. So it is built. So what else I need to push my image to Docker Hub? The next step is to tag it. Yeah. So I have tagged it. Now I'll push it. So let's just wait till image is pushed on Docker Hub. Okay, so image is pushed on Docker Hub. So the first thing is when you deploy an application, a container on Kubernetes, it is deployed inside a pod. So what is a pod? So a pod in Kubernetes is like, it is the smallest deployment unit in Kubernetes. So when you deploy your application, it will be deployed inside a pod. And a single pod can have multiple containers in it. So if you are deploying like 5 containers in the same YAML file, then it will be deployed on a single pod, and all those 5 containers will be inside that single pod. So it is the simplest, like the minimal unit of deployment in Kubernetes. So everything you deploy, it will be deployed on inside a pod. Okay. So to access like CLI commands of Kubernetes, you have to use kubectl. So in Docker, we use Docker space images build run etc. So in Kubernetes, you use kubectl. So if you write kubectl get all and then press enter, it will list all the things. Let's say when I write Docker images, it will list me all the images. Sorry. And if I write Docker PS, then it will like list me all the running containers. So just like that, if you write kubectl get all, then it will give you a list of all the running things inside Kubernetes. So there's one more thing which I should show is if you write MiniKube dashboard, then it will open a dashboard for you. So when you are running things in locally, then you can use the dashboard to visualize things, like see how many containers are running or how many services are there and all etc. I'll show you this once I deploy application. So I built image, tagged it and posted on Docker Hub. Now I want to run the image. So either I can use Docker run and then the image, or I can deploy the image in Kubernetes. So we'll do the second way, Kubernetes. So I want to deploy my application inside a pod, like one instance of container. So when I write kubectl run, then you need to give the name of the application. So I'll give the name Flask app, then ---- image, and then you'll need to give the name of the image. So Purvesh R, and then Flask app. So it gives like a pod is created. If I go to this dashboard, it shows like there is one workload and it is like one pod is running. So if I write kubectl get all, I'll see like there is one pod running my application, and you can even refine the things like get pods. If you want to just get the pods, then it will just give you this. So now my application is running. So remember when you ran the application in Docker, you need to map things like -p and then your port and other port. So let's see what is the port here. So my application is running on port 80. So in Kubernetes, by default, you can't access anything because let's say, so like I'm running Kubernetes on my local. So there is a cluster. There is this cluster here and my app is running inside this pod. So this is me. So I can't access this directly. So how do I do it? So with when you run in Docker, you just map the port. But when in terms of Kubernetes, you have 3 options. One is cluster IP, one is node port, and one is load balancer. So there are 3 ways you can use, and mainly you will be using node port or load balancer. So when you want to expose a container to the user, then single container to a user, then you can use node port. But let's say you have 15 containers of same application, then you can't map 15 application to different port. you should use a load balancer on top of it, and the load balancer will handle the communication, and you can just request to load balancer and it will handle everything. So node port, load balancer, and cluster IP is like you have 3 different containers running on a single cluster, and you want to communicate with internally inside the cluster. In that case, you use cluster IP. So in your assignment, you can either use node port, cluster IP, or load balancer. But you should follow the best practices. So follow the instruction given in assignment and then use the thing appropriately. Okay, so I want to expose my application now. So when you expose an application using node port, load balancer, or cluster IP, it is called a service. So if I write kubectl expose pod/flask app, so my app is running on port 80, and type equal to, there are 4 examples. So load balancer, node port, cluster IP, and external name. So I'll use node port. So I have one single instance of my application, and I want to access it in my machine. So I'm using node port. I'm mapping it to port 80, which is the port in which my application is running. So if I click this, it has created a service. So when you expose anything, it creates a service. So it is called service basically. So if I write kubectl get all, then now I have a service with the name of Flask app. It is a node port, and this is like how it is mapped. So the one thing you should remember here is like if you do this in GCP, then you don't need to do the next step which I'm going to do. But if you're doing it local, then you should you will have to do that. So the step is MiniKube service and then Flask app. So when you write this MiniKube service Flask app, it like gives you a URL through which you can access the app. So it is just an extra step which you have to do in like local, not GCP. So remember that. So my app is running on this right now. So if I go to the browser, then my app is running. So we have deployed an application on Kubernetes. So any questions so far? Yeah. Yeah, this one. So this is like by default service of Kubernetes, which is like running on port 443, which is HTTPS port. So this is like the by default one. It will always be there. So other than that, any questions? Now you know how to deploy application on Kubernetes. So we haven't used the capability of Kubernetes because we have just like created a same thing which we do in Docker. We have not created multiple containers and all. So right now we have only so far created one container and deployed it on Kubernetes. So next part is, so there are 2 forms of deployment in Kubernetes. One is called pods and one is called deployments. So what is the difference between them? So I'll just show you. So when you want to deploy something, then in the pod, then you write this, which I just did, and then image name. So remember this command when you want to deploy application inside a pod, like single pod. But the thing you should always do is to not use the pod but create a deployment. So how to do it? So you write kubectl create deployment, name of the deployment. So let's say I'll give Python app, and then image equal to r, and then Flask app. So if I write this command, then it has created a pod, and it has created a deployment, and it has also created a replica set. So when I deploy anything on a pod, it just creates a pod. But when I create a deployment, it creates a pod, a deployment, and a replica set. So what is it? So the main thing about it is like when you create anything, when you deploy anything using deployment, it creates a replica set. So there is a feature in Kubernetes which is self-healing, which means that, let's say, again, going back to the Instagram example, let's say I have 500 instances running, 500 containers running, and I have base limit of, it should at least run 500 containers. It can go above it, but at least 500 containers. And due to some issues, my 100 containers got crashed. So what Kubernetes will do is like, it will create 100 more instances again. So it will always have 500 instances, and it is called self-healing capability. So how does Kubernetes do that? So I'll come to that later. So again, my application is like another container is running using this, and I have created a deployment and replica set. So let's do one more thing. Now I want to have 5 instances of my application. So what I'll do is like kubectl, then next command is scale, then name of the deployment. So deployment, and then Python app -- replicas equal to 5. And if I write this, then it gave me the Python app is scaled. So I'll just write kubectl get all, and now 5 pods are running. So now I have 5 containers running a single application, and there is, so what is the replica set? So when you want to scale your application up or down, this replica set is used. Like that's why when you create a deployment, it creates a replica set. So if it has already a replica set, then it is faster to create new instances, new containers of that image. So that is the like the thing behind the replica set. And here it is 5 desired, current 5, ready 5. So like my 5 instances are running. So now I want to access this like deployment. So how should I do it? Using cluster IP, node pod, or load balancer. Load balancer, because I have 5 instances. Either I can expose 5 containers differently or use one load balancer and then let it handle everything. So I'll do the second one, load balancer. So kubectl expose deployment. You can even write deploy Python app. Port was 80 and type is load balancer. So it says this service is exposed now. So again, if I write kubectl get all, then I should have a new service. So this Python app service now with a type of load balancer. Also, like we can see this in the dashboard as well. So there is one deployment, there are 6 pods running, there is one replica site we just saw in the console output. So if I go to pods, then I have 6 pods. If I go to services, then I have 3 services. And if I go to deployment, I have 1 deployment. So you can like see this in GUI, or you can use CLI, whatever you like. So now I want to access my application. So if I write kubectl MiniKube service and then name of the service, which is Python app, then it is now running on a load balancer. So let's just verify it. So the next command you should remember is, first of all, I'll write get all. So how to see logs of the pod, like how to see the logs of your application. So I'll just copy this pod. So the command is kubectl logs and then name of the pod, and you can write -f to follow. So it will keep this open. So now if I refresh this, it won't have request because it could go to some other instance. So it will only come when the request comes to this one. So that is how the load balancer works. It sends requests to different containers, and like behind like it could like follow round robin or any etc algorithm to send the request. So to see the logs, you can fire this logs command. Now another important command is when you used the Docker, how did you get inside the container? Docker exec, right? So there is a command in Kubernetes as well. kubectl exec, then name of the pod, same as docker -it, and then bash. So now you are inside the container or like pod. And now if I do ls, then this is my image, and then if I go to outside path, and then this is like the base Linux file system. So it works same way as docker exec. Yeah.
So, what can I do?
Yeah.
Can we do docker ps here?
Docker ps. Yeah.
So it is not like cannot do it inside the pod. So the container is in the pod, right?
Container inside pod, yes. So like you are using Kubernetes, not Docker here. So you will need to use docker kubectl get all command, not the docker ps command, because it is like running on Kubernetes, not the Docker. It is using Docker behind the scene, but in front it is using Kubernetes. So like you should use docker ps, but kubectl get all or kubectl get pods, you can use that if you want to just get the pods, or kubectl get deployment, or kubectl get services, or you can write svc, which is also work. So you can use these things to get like the list of running instances. So any doubts so far? Okay. So I showed you this get command, run command to deploy a pod, create a deployment, scale a deployment, expose a service. Now we'll use this one. So first of all, let's just delete the things which we don't need. So how to do that? So kubectl delete pods/flask app. I want to delete this first instance which we created. So I'll just delete it. Let's see if it is deleted. It will take some time to delete, so I'll just delete deployment as well. Okay, so it is terminating. So when you delete a deployment or pods, it doesn't delete the service. So a service will be still there. So you should you will have to manually delete it. So kubectl delete service flask app, and so you can even like delete multiple service like this. So it will delete everything. So now I only have one like base thing. So I deleted everything. Okay, so going to next part. Okay, so now comes so like Docker, when you want to run a container, you don't run docker run always you always like use Docker Compose. So you just like write Docker Compose up and it will deploy your app on server, right? So in this case as well, you don't like run kubectl run pod and then name of the pod and then image, etc. You always use the deployment file, like YAML file, because you can't remember everything, right? So it's better to create a YAML file and then do the deployment. So this is like very basic YAML file to deploy a pod. So the convention is like, first is the API version, which is like the latest one you should use. Then what kind of thing you want to deploy. So it can be a service, deployment, or pod, or etc. There are many things in Kubernetes. So I want to deploy a pod. Then in the metadata, you need to specify the name of the pod. So it is Flask app. Then inside the spec, there is this key called containers, and in that you need to give the image name. So it is like basic what we do in Docker. The next thing is image pool policy. So like whenever you deploy something in the pod, if you write this, then it will always pull the image from Docker Hub or any repo of images. If you don't write this, then it could take the local image, which is already there. So it's better to write this because you're not going to build the image when you deploy something on Kubernetes. So you should always use the latest image on the Docker Hub, right? Or any repo. And then the mapping of the port. So my app is running on port 80. So this is the like the minimal like YAML file for deploying the pod. So how to deploy it? So let's go to. Okay, so the command to deploy a pod or anything in Kubernetes using the YAML file is kubectl apply -f is for file name and then name of the file name. So I'll write Flask app here, and then if I press enter, then it is given me a pod is created. And if I write kubectl get all, then my pod is created. So if I want to create a service in it, then I can just write the like things needed for the service, and it will create a service for me as well. So you can either do in separate files or a single file, whatever works best for you. So this is like how to deploy a pod using YAML file. So any question in this? Okay, so moving to next example, which is so we'll deploy a new pod, which is Nginx. So we should always deploy one Nginx server in every lab. So so I will show you first one thing which you will have to do for your Kubernetes assignment, or it is very like important thing here. So if you have went to the assignment, you need to create a persistent volume for your application. So the first API is store file, right? So our application will send a request to your store file API, and then you will save that details inside the persistent volume, not inside your container, inside the persistent volume. So what is a persistent volume? So let's say I'm using Google Kubernetes Engine, and if so like there are storage options in Kubernetes in Google GCP. So just like we have in Amazon, we have EBS, Elastic Block Storage. We have same way persistent volume in Google. So your application is running on a Kubernetes engine, but you need to store files of 100 gigs, anything like that. So you don't create an instance with the size of 100 gig. You create a different storage and connect it to the instance. That's how it works. So that's what you should do in your assignment. You'll have to do in assignment. So what is persistent volume claim? First of all here. So a PVC is like when you execute this, then it will create a persistent volume claim for you. So it will, so like you will have to pass how much storage you need. So first of all, I'll just fire this and then explain it. kubectl apply -f and then part to file. So it has given me a PVC claim is created. Now I'll open this Nginx and then explain you later. So I deployed the Flask app. Same as everything is same, like the only thing different is the image name. So I had Purvesh R. Here I had Purvesh R, here I have Nginx. Other than that, everything is same. This thing is same, and this thing is also same. So like coming to the next part is this volume. So when I created the claim, I gave it name of my PVC claim. So when I want to attach a persistent volume to my container, I'll have to mention the claim name here. So persistent volume claim and claim name here, and you can give any name you want for this volume name. And then I'm mounting this path inside my container to this volume. So let's go back to the Docker volume concepts. So when you create a volume, it creates some folder on base OS. So like if I create a volume on my machine, then it will create a volume inside a container, but all the files will be stored in my local machine, in my file system, right? So same as in Kubernetes, when I did a persistent volume claim, it created a storage space with 1 gigs of memory. And when I wrote this thing, mount my storage, then when the container is running, it will mount this storage to my container. So it is it looks pretty complex, but it is very simple. When you do practically, then you will understand it. So any questions so far here? sorry,
Mounting.
mounting. Yeah. So you got the persistent volume claim part, right? I created 1 gigs of persistent volume claim. Now I'm defining this claim here, and I'm referencing this to here, and to which path inside my container I want to mount this volume. So when you do the bind mount, you wrote some path, right? Temp / something like this, or etc / something like this. I wrote the same thing, etc custom folder here. So first of all, I claimed a storage of 1 gig, then I defined it here, and then mounted it to my container. So I did these 3 steps. And next thing I'll do is kubectl apply -f and enter. So now I'm deploying this nginx pod. So let's see if it is running. So this is running. So I'll fire here so that it is visible. So what I'll do is kubectl exec pod nginx app -it and bash. So I'm inside the container. If I do ls, then cd etc and then ls. So I created a folder called custom folder. So I should have a custom folder here, and this is where, so this folder is mounted to persistent volume. So everything I stored inside this folder, it will be stored inside the persistent volume. And let's say, going back to the assignment requirements, let's say you have 2 different containers and you want to share a storage between them. So what you do is you create a persistent volume and connect that volume to both of the containers, and that way both of the containers will be able to access a file. So it works like a bind mount, but it is not bind mount. It is a separate volume. Now I think it should be clear to you the concepts of persistent volume. Yeah.
So how is deployment reference Nginx YAML node to run PVC YAML?
How does this file?
Yeah, so the configuration of IPVC claim is in separate YAML.
Yeah. So I executed this YAML file before this one. So if I write kubectl get persistent volume claim, then once I wrote kubectl apply this command, I execute this command beforehand. So I already created a persistent volume claim. So now this is created. So now going back to this file, now it knows like there is one claim here with the name of this. So what it needs to do is like it will pull the image of nginx. It will see like if this exists, then it references this here and then give some path here. So like to connect, so like in order to use the persistent volume, you need to first claim it. So you can do this in a single file or different file, whatever you want. So if you want to run this all in a single file, then you can use that. But I feel like it is easy to debug things if you separately deploy it, because like I won't know if error is in my PVC or pod or deployment, etc. So if I have different files, then it will be easy for me to debug it. So that's why I use different files, but feel free to use a single file. So any question in this? Yeah.
This is a single part, right?
Yeah, one part.
So if you want in one part, let's say 2 containers.
I think this is the syntax, replica and then 10, whatever, however pods you want.
So replica and scale are different.
Scale is like a command to scale it. So if you write kubectl scale, then you write name of the pod, and then inside scale you need to mention replicas. So you mention like number of containers you want. So it works like same here. But when you create replicas, you should always use, like if you want to use multiple containers, always use deployment, never pod. Okay. Pod is like just for this learning purpose, but you should always use the deployment, not the pod. So any questions so far? Okay, so this was running Kubernetes locally. Now we'll go to the GCP. So when you go to GCP and write Google Kubernetes, like Kubernetes here, then it will like give you Kubernetes engine option. And when you like open it, it will be something like this. So when you first open this console, you won't have this cluster here. So I create this beforehand because it takes like 5 minutes or 7 minutes, something like this. So I didn't want it to waste time here. So when you create a cluster, it will take like 5 to 7 minutes for you to create a cluster. So like in the assignment, you'll need to create this cluster using Terraform script. So remember that using Terraform, you need to create this. You can create this using console. It is very simple. That is why you need to use Terraform. So like give the name and then other things like networking, automation, metadata features, or which type of like computation you need, how many root GB of like storage you need. If you need 2 CPU, like 4 GB memory or any big or small instance, so you can select this using console, but you can also do this using Terraform. So if you don't know Terraform, then Terraform is like infrastructure as a code service. So it is used to create, like to provision things inside a cloud. And it can be used if you write one Terraform script for AWS, then it will work in GCP. So it is like cross platform available. So you create Terraform script to provision something, which means like to create a EC2 instance, to create a Kubernetes cluster, to create a storage, to create a Lambda function, whatever is created on the console, you can use Terraform or CloudFormation to provision it. So it is one way of using creating the things in the cloud. And why it is needed? Can anyone answer? Why Terraform or why CloudFormation scripts are needed? Okay, so going back to Instagram example, so I had 500 containers running. Now I got hacked and they deleted everything from my cloud. So I have 0 service running now. So imagine at the scale of Instagram, how many different services which will be needed to run their applications. So they'll need 500 servers, then 500 databases, and etc. And then thousands of Lambda functions, let's say. So I'm not going to create one by one like the instances and Lambda functions. If I have a CloudFormation script, I can just run the CloudFormation script and it will create 1,000 instance 500 Lambda functions. So it is that handy, and that is why it is used. So you don't write things, you don't provision things manually, but you should use CloudFormation or Terraform script to provision your thousands of instances or databases, etc. And then you can deploy your code in the instances. You can also automate this. So that is why Terraform is used. So in the same way, for this assignment, you'll be using Terraform to deploy a cluster on GKE, Google Kubernetes Engine. So as a programmer, you are not going to use the console, but you should use the Terraform, CloudFormation, CLI, SDK, whatever it is. Because console anyone can use. So you should differentiate it. So going inside a cluster. So I have already created a cluster. I'm going inside a cluster. So if I click on this connect and open it, then it opens a CLI for my GCP. So let's just wait till it is open. Okay, so I'll just zoom in a little bit. Okay, so I have run a Kubernetes cluster on GCP and I have opened a CLI command prompt here. So if I write kubectl get all, then it will give me this. So now we are running Kubernetes on GCP, not local. So now we'll deploy an application on Kubernetes Engine. So let's just go back here and go to this service called artifact registry. So you know Docker Hub. So this is Docker Hub, and anything you push in the Docker Hub will be shown here. So artifact registry is the Google version of Docker Hub. This is the where you store your private repo or public repo or images, like images in the GCP. So you use artifact registry to store your images. So to do that, first of all, I'll create a repo. I'll name it my image repo. I'll select Docker region as US East 1 and create. So I have created a repo on artifact registry. I'll open it. Then I'll click on this. So before doing this thing, you should install Google CLI on your local machine. And if you do this, then after that it will work, but it won't work directly. So you need to first install Google Cloud CLI. I have installed it because it takes some time. So whatever your OS is, follow the instruction and then install this G Cloud CLI on your machine. So I have created a repo on artifact registry. So I want to push an image to it. So how do I do it? So remember in the start, I created an image and then we tagged it and then we deployed on Docker Hub. And the name of the image was Flask app, right? So now I want to deploy that image in GCP, artifact registry. So how do I do it? So I created a repo. I'll just copy this thing here. So I'll write Docker tag Flask app. So the app I want to tag, and then on the right side, I'll paste this, which I copied here, and then give the name Flask app. So the difference here is like when you use Docker Hub, you write your Docker username and then slash and then image name. Here you write your artifact registry's path, repo name, and then image name. And then if I press enter, then I'll copy this and then Docker push enter. So if I do this, repo may already exist. I'll just delete this one and create it again. I think I've used this name before, so I'll edit it. I'll tag it again. Not sure why it is not working. I'll first like explain other things because we have limited time. After that, we'll debug it. So when you push an image to GC artifact registry like this, then it will push an image to this registry, and that way you can store your images on artifact registry. So if you go to the assignment document, you will need 2 containers, and you need to store those containers in Google's source repository. So what is it? So if you Google it out, like Google source repository, then it will open this portal. So it is like GitHub version of GCP. So you can create your repos in this and store your code here. So it is alternate to GitHub or code commit, etc. So what assignment requires is like to create 2 repos in Google source repository. So you need to create 2 repos. Then what is cloud build? So this is cloud build. So do you know what is CI/CD pipeline? So it is continuous integration and continuous deployment. So anything, so let's say I have a CI/CD created and I have production application. So anything I push to main branch, it will push the code to my servers and will restart my application. So this is what CI/CD pipeline does. So cloud build is a feature like service. Using this, you can create a CI/CD pipeline. So you need to configure a pipeline inside a cloud build. So you can use, it is pretty straightforward. So you can create a pipeline in cloud build, connect it to your repo, and you can specify if you want, if anything is committed to main branch, then push it on, then trigger this cloud build. So the next step is when this pipeline is triggered, you need to create an image and store it in artifact registry. And then you will need to deploy the image to GKE. So like you'll need to deploy your containers in form of pods to GKE. So this pipeline should build your image, push the image on artifact registry, and then like deploy your application on GKE. So this pipeline should do that. And then when you deploy anything on Kubernetes, so like you will have two containers in form of deployment, and then you'll also need a persistent volume, which will be shared among the containers, and you should follow the requirements as it is. So you can use cloud build to create a pipeline. You can use artifact registry to build and push your code, push your image on this, and you can use Kubernetes engine to like run your containers. So that will be like the assignment requirements. Now let's try this. Any question regarding the services? I'll just build the app again. I'll just reinstall it. It is easier to do that. Meanwhile, it is installed. Any question in the assignment? How many of you have not read it? So like it will have so many errors when you like deploy it. So like I'll highly recommend you to start early as possible, because you will face so many issues in this. In the last term, like many students faced a lot of issues regarding the Kubernetes, Terraform, etc. So like if you keep it till the last day, then it will be very hard for you. Okay, so there are some like authentication issue for me, so I'll need to uninstall and install again, but I'll re-record that part and like upload in the video. So the only part left was like pushing the image to artifact registry and then deploying your code to GKE. So if I run kubectl run nginx app image equal to nginx, then it will create a pod of nginx. So whatever you did in local machine, it will just work fine in this GCP as well. So like it is the same thing. The only difference is like you are running first in the local when you use MiniKube, and in this it is running on like GKE. So only difference is that. Otherwise everything is same. So after this lab, you should be able to do this part at least, deploying your application on Kubernetes, the configuration of PVC. So you'll be able to do this part, and Terraform is self-learn part. Cloud build is very easy. So if you just see the documentation of cloud build, it will be very easy to create a pipeline. So major part is like this one, to successfully deploying your app, and it is working as you expected. Other than that, I think everything else is like it won't take much time. So yeah. So any question for the lab? Yeah.
How does GK
Sorry, how does GK?
Google Kubernetes engine, is there a separate service?
Oh yeah, it is a service by Google. Also, like Kubernetes was like developed by Google, and it was open source in 2013. But they had Kubernetes for 15 years before that, so like they have a lot of experience in Kubernetes. So that is why like Google GCP is like the major player in the Kubernetes part, because they developed it. So that's why like everyone used GKE for Kubernetes engine. Other than that, AWS is like pretty front end. So that. Any question other than that? Okay, so I did the commands which I showed in the lab here, and if no one has any question, then we can conclude the lab. Okay, thank you. Okay, so I'll go to GCP. So I've already created a cluster on GCP because it takes time to create a cluster. So that's why I already pre-built this cluster of Kubernetes on GCP. So before doing this thing, I'll show you first artifact registry. So this is called artifact registry, and just like Docker Hub, we can also we can store our images here. So we can have either private images and store our images on this, or you can also have a public image, like you can make it public so that anyone can access it. So for example, when you work in a company, then you want it to be private, and if you're using GCP, then you would use artifact registry to store your images. And if you're using AWS, then you can use ECR, which is Elastic Container Registry, which is also used to store images. So it's like based on your interest or requirement, like you can either use Docker Hub, artifact registry, or ECR. So here I'll create a repo and name it as app. It is in format of Docker. Region, I'll select US Central one, and I'll keep everything as it is. So I'll click on this create, and it has created a repo. So you can use the setup instruction and go through this document. But I already configured Google Cloud on my machine, so I can directly work with GCP through my machine. But you can always follow the documentation to do that. So once the repo is created and you have configured your Google Cloud on your machine, then now the first step is I want to push my image on artifact registry. So I have created an artifact registry, and I can click on this copy button. So I want to push this app image to artifact registry. So to push something, you'll have to first tag it, right? So I'll tag it, and like I have copied this from here. So this is the path, like this is the location of the file, and then this is my project ID, and this is the name of the repo, and I'll write the name of the image. I can write it anything like demo or app. I'll keep it as app. So this is the name of the image. This is the repo name. This is the ID of my project of GCP. This is the location where the images will be stored, and this is like by default path. So if I press enter, and if I write Docker images, then there is this new image, like it is tagged. Know that they are referring to same image. So all these three images are the same one. This one, they are just the reference to it. So if I want to push it, Docker push, and enter. So now this image is being pushed to artifact registry. So let's just wait till it gets pushed, and we'll see on the console. It is really like easy to use artifact registry. You just need to do the authentication locally, and just like that, you can create image, tag the image, and then push it, and it is pushed. So if I refresh this page, I should see an image. Okay, so here it is. So this image is deployed on artifact registry, and from here, if I open this, I can see like this is. So you can directly deploy it to different things like Cloud Run, GKE, GCE. So from just here, you can deploy your images to anywhere, like the compute resources which are provided by Google. But we'll do it from console. So I'm going back to the Kubernetes engine, and I'll first connect with the Google Cloud Console. Okay, so the console is running. So if I write kubectl get all, I should get a cluster IP which is default. Okay, so right now I have nothing running on Kubernetes. So like I did in local, I want to create a deployment and run the image which I have just pushed it on this artifact registry. So just like local, I have to run the command ctl create deployment. So name of the image is, in the local we have used the Docker Hub, but this time I'll push like get the image from artifact registry. And if I press enter, then deployment has been created. So kubectl get all. So there is one pod, one deployment, one replica set. I want to scale it to 3. So there are 3 pods now. So let's look it from the dashboard. So there is one deployment and there are 3 pods. So if I open this deployment, I'll see like there are 3 pods which is running, but we can't access the pods yet because there is no service here. So just like we did in local, we can expose the deployment. So it was deployment app, it was 80, and since I have used deployment and I have created 3 pods, so I'll create a load balancer instead of node port. So there is a load balancer now. There are 3 pods. There is a deployment which is running 3 pods, so we have everything. I'll execute get service command. Service is still creating, it is in pending state. If I refresh this, you see this, it is still in pending, so let's just wait. So it is created. So if I write this command again, then you see here I am getting this external IP address which I didn't on my local machine. So if I write kubectl get service, I don't get the external IP address, but on the Kubernetes engine you'll get an IP address. I'll have to use MiniKube in order to get the IP address. So there is one less step on the this. So you can always use the dashboard, but like for learning purpose, you should use command line in order to create things. So this is the external IP address, and it is running on 30530. And let's see if it works. It should work. Okay. So Kubernetes engine will give you an external endpoint, and since like you can directly access it without the port, so if I go to this URL, then I'll be able to access the app on my machine. So again, this is load balancer, and whenever I refresh it, it will redirect me to any of the pods, like any one of the 3, and then the pod will serve me. So in this lab, you learned about Kubernetes getting started and how to create deployments or pods, and how to deploy your app on Kubernetes, how to scale the app, how to expose the app, how to use load balancer. And I think you know the whole flow now, from creating an app, building an app, to deploying the app. And this lab, in the scope of the lab, is to you can learn about the CLI. So you'll have to learn about the deployment.yaml file and about the persistent volume. So it's on self-running part. And yeah, so I think this was all from the lab. So do let me know if you have any questions or doubt in the lab. And thank you.